In this video, we're going to look at topic 86, example 4, multiply a rational expression by a polynomial. The nice thing about this example is the process is done exactly the same way as the previous example, example 3. So let's rewrite this. We have x plus 2 over x to the 4th minus 16 times x cubed plus 4x squared minus 12x. So all we really need to do here is we're just going to create this, make this a fraction, and we're just going to put the denominator as 1. Everything else that you do here is done the same way that we did in the previous example. So you're going to follow your same steps. You're going to factor, state the domain, and then multiply and simplify together. And remember the order there. You can do whichever one you want first. They can be mixed in, but multiplying and simplifying kind of work in as a group. So let's look to factor. My numerator, x plus 2, there's nothing I can do with that, so we're going to leave it alone. My denominator, all right, this x to the 4th minus 16. X to the 4th is a perfect square, right? X squared times x squared gives me x to the 4th. That's a 2. So that's a perfect square. And then 16 is 4 times 4. It's also a difference, so that means it is the difference of squares. So we can factor that into the product of two binomials, which would be x squared plus 4 times x squared minus 4. All right, so that would factor into these here. I'm going to finish factoring this left side before I get to the right side. The x plus 2, let's put that in parentheses. Again, we said we can't do anything with that. But what happens here is this x squared to minus 4 is the difference of squares again, because x times x would give us x squared, and 2 times 2 would give us 4. So it's our lucky day, and we get to factor it further. The x squared plus 4, this one here, cannot be factored because it is a positive 4. It's the sum of squares, which would give us complex numbers, so we can't factor that one. So this would become x plus 2 times x minus 2. And then we can multiply. Okay. So just be aware of that. Always check to make sure the problem is fully factored. My numerator, now we're going to look here. My numerator, first thing I look for is GCF. They all have an x in common. So let's factor that x out. So I'm going to do x times x squared plus 4x minus 12. Can't factor 1, the 1 just stays there. All right, now I need to look to see if I have factors of negative 12 that have a sum of 4. Options are 1 and 12, 2 and 6, 3 and 4. Something here has to be negative. Negative 2 and 6 do give me a sum of 4. So this can be factored into negative 2 and 6. So my numerator, do not forget about that x. We're going to bring the x down, and that'll be multiplied by x minus 2 times x plus 6. Again, just leave that over 1. From here, you can cancel out if you would like to, or you can put everything together. Again, I'm going to put everything together so that I don't cancel out and make it difficult to read some of this work. So my numerator would be x plus 2 times x minus 2 times x plus 6. And we didn't do the domain, so we have to do the domain. I'm going to finish this step and then we'll go back. My denominator will be x squared plus 4 times x plus 2 times x minus 2. Okay. Before that, we should have done the domain. So let's take a look at our domain here. Domain would be all real numbers, except those which make the denominator undefined. So the denominator is 0, or the fraction undefined, except x equals. Let's look at these two pieces first. X plus 2, that tells me that x cannot be negative 2. X minus 2 tells me that x cannot be positive 2. Now, the x squared plus 4, if I set that equal to 0, or not equal to 0 really, and I subtract 4, I get x squared equals negative 4. And if I try to take the square root, I'm going to get a complex number I. And this would actually be positive and negative 2i if we really want to finish it. Positive and negative 2i are not exceptions to our domain because they're not real numbers, they're complex numbers. So it's impossible for that x squared plus 4 to be equal to 0. So there's no limitation there. We don't have anything that's added to our domain from the x squared plus 4. So my domain is complete. Just can't be negative 2 or positive 2. All right, now let's go back up here. All right, so now we're just going to look to simplify. Sorry, we're going to simplify. Anything that is a like term from the numerator and denominator can be canceled out. I see I have an x plus 2 in the numerator and denominator. That can go away. X minus 2, numerator and denominator, that can go away. So my leftover pieces are x times x plus 6. And in my numerator, misspeaking here. And then my denominator would be x squared plus 4. Okay. It's kind of a matter of, I don't want to say debate because it's not like people are really debating strongly over this, but sometimes you can stop here. There's really nothing wrong with this. There are some that believe you should take that x and multiply it in and write x squared plus 6x over x squared plus 4. Either method is fine. I'm okay with both of them. I think they're both appropriate. They state your solution. It's good from there. What you do really need to be careful of though, let's say we do go here. Really, really important, you do not cancel out the x squareds, right? This, you cannot do that. Right. Remember that the numerator, this is tied as a group here. This denominator is a group. So unless I can cancel the entire group, I cannot cancel any part of it. So do not cancel out the x squareds if you do decide to distribute that in. All right. Your answers will be these two. You can use either one. Okay. Either one works. Okay. I would recommend just stopping here. All right, we're done there. There's really not much else we can do. So I would say just stop there. Do check to make sure that you can't factor anything else and can't cancel anything else. So occasionally you might need to distribute, but for this specific problem, nothing would be eliminated. So you're okay. That is all. Multiply them out, factor them, and then slowly cancel things out. Take your time. And again, it all comes down to factoring. If you factor correctly, you should get these problems correct.